Divya, are you there?
Yes, I'm here.
Yeah, so is the recording on still?
Yes, actually, somehow I don't know. There might be some glitch that recording was not going on. So I just started it again.
Okay. So I should continue. I can continue, right?
Yes, please continue.
Yeah. Okay. So now let's go to today's lecture topic. And before I explain you what is a smart contract and some other stuffs, I would like to know from you, for your definition, how do you define a smart contract? So you can see again on the screen. Again, you need to go to this website, menti.com, and use this new code. And when you are there, you will get the question. So what is a smart contract? You need to write down, put a definition that you know. So I'm going to now put the code in a chat so that you can join. 4, 3, 2, 1, 7, 2, 4, 5. Yeah. Okay. Okay. Someone has answered. So whoever it is has written. So a smart contract is a self-executive contract, or yeah, a self-executive contract stored on a blockchain. Yeah. Yeah. A contract. A, yeah, it's a self-executing executing contract. Yes. Good. Smart contract are self-executing code. Okay, a little bit better definition. Smart contracts are self-executing code that run when certain conditions are met. It is stored on a blockchain. Yes, this is more. Uh, this is a little better. Yeah, and then transactions which are executed automatically by a computer program. Yeah, that's also, yeah, you can think in that way also. It is program that executes automatically when predetermined terms and conditions are met. Yes. Self-executing agreement stored on a blockchain that automatically executes when predetermined conditions are satisfied. Okay. So I think what I can see, smart contract is a piece of code that runs when a condition is met. Okay. Then contracts stored on a blockchain that are automatically executed. Okay. So basically, it seems you know about it. Okay, so someone has a program that controls transfer of digital assets. Yeah, you can also think that way. A program that controls transfer of digital assets. So here, what I can see when you are defining the smart contract, you are also explaining the purpose of it. For instance, here someone wrote the transfer of digital assets. A self-executing program stored on a blockchain that run a predefined conditions are met. It automates transactions. Yes. Yeah. And then, yes, someone has also written like, think of a smart contract as a digital agreement that enforces itself. Instead of relying on lawyers or middlemen, the terms of the contract are written directly into the code. Once it is set up, it runs a something. Okay. Okay, so here you are saying it in a much more broader way, and its actual purpose even. Okay.
और तो कुछ नहीं लग
Yeah.
रहा.
And then this is the also interesting one. It is a business logic implemented to perform transactions on a blockchain. Yes, you are absolutely right. Okay, and then here, this is also interesting. A software program that binds the two parties on certain conditions. So as it is a contract, so this means that it binds two parties. You're right, which should be followed by both parties. Yes. And then if the smart contract is stored in blockchain, then miners, and then if it is this proof of work algorithm is there, so miners validate. Okay. And then executing program, it works like digital contract that doesn't need intermediaries, which ensures security. Yeah, I think this is a little bit problematic definition. That doesn't need intermediaries. This is true, but which ensures security, it's not really that. I mean, it is secure, but as there is no intermediaries, so basically this means that autonomy is high. So you don't need to rely on the intermediaries. And smart contract is a contract done smartly. No, this is a very vague definition. So, but by now, I think you have understood, seeing other definitions, what is a smart contract. And then I like smart contracts. Okay, yeah, I like it too. Okay, so last one. A smart contract is a self-executing program stored on a blockchain that runs when predefined conditions are met. It automates agreement between parties without the need for intermediaries like banks. Yes, absolutely. Yes. Okay, then I have another question. Thank you for your answer. And based on that, I think you already, those who didn't know what is a smart contract, probably got some ideas. Now, again, look at your phone or your computer where you are in this menti.com, and then try to answer this question. What is Ethereum virtual machine? Let's see what people write. Yes. So somebody has written it is decentralized runtime for executing smart contracts. Absolutely. And then a way to make Ethereum-based DLT application. It's not a way, but it is a runtime environment. Then Ethereum virtual machine is a runtime environment, yes, for smart contracts on the Ethereum blockchain. Absolutely. It provides an environment to execute a smart contract. Yes. So Ethereum virtual machine is a decentralized that executes smart contracts and decentralized applications on the Ethereum blockchain. Absolutely. Okay, then there is also an interesting definition, a computational engine of the Ethereum blockchain. It is a decentralized runtime environment that executes smart contracts and ensures consensus across all Ethereum nodes. Okay. Okay. And then, okay, everyone saying runtime environment, which is correct. EVM executes smart contracts or self-executing programs written in languages like Solidity, true, by processing their bytecode. Yes. This bytecode concept comes later. So basically, when you compile, then the result of compilation is a bytecode. So that you deploy. So that's why this is also a right way of explaining, but it is a little next level. And then the Ethereum virtual machine is a runtime environment. Yes. Yes. And then it is this decentralized computation engine. Okay. Is there anything? Yeah. So it is similar to JVM, which provides a way to run bytecode of smart contracts. Yes. Okay. And then what else? EVM is a runtime environment. Okay. The Ethereum virtual machine is a decentralized computer that runs smart contracts and dApps on Ethereum. It ensures security, transparency, and consistency, powering decentralized finance, NFTs, and more. Yeah, so decentralized finance, we will talk about that also, maybe not today, but maybe tomorrow. Then what else? Is there any other interesting things? Okay, so JVM, we are talking about. Okay, so what is this? JVM, AC, JVM minus Java, okay, equals to EVM. Okay, why does EVM runs smart contract? Okay, all right, but anyway, I can see that you also know what is Ethereum virtual machine. But we will talk about those a little bit more in my slides. Now I will go back to the slides. And those who didn't know about Ethereum virtual machine, by now they know. Okay, now I will go to the slides and then continue. Yeah. Okay, now
70 समोसे चाहिए।
samosa nahi chahiye. Okay, so let's move on. Let's move on. So already you guys have defined smart contracts. So, all the definitions, or most of them, I think 99% definitions that you provided are correct. So I have some definition from, some course or somewhere. So smart contracts are simply computer programs that execute predefined actions when certain conditions within the system are met. So you already wrote about it. But then the next point is smart contracts provide the language of transactions that allow the ledger state to be modified. So when the smart contracts are executed, the ledger, the blockchain, a new entry comes. The states are changed. And smart contracts can facilitate exchange and transfer of anything of value. Anything of value. It's just not just about money. Anything of value. Shares, content, property. So it can exchange anything and transfer anything of value. So that's a smart contract. You already know. So this is, and from here also, I think from when I asked you what is a smart contract, somebody also mentioned that this smart contract is done between parties, maybe two parties, in its simplistic form, two parties. So here in this figure, we have a similar situation. So there is party one and then party two. Let's assume that party one is a company and party two is the consumer, is an individual. And then they decided to make a contract on something. For instance, we can think this way, that party one is electricity service provider and party two is, for instance, you. And you want to buy electricity from the electricity service provider. And hypothetically thinking, you can think that, well, you can say, you can agree with the electricity service provider that you will make a contract, electricity contract with the service provider only when the market price of the electricity is below certain number, certain value. For instance, in 3 cents per kilowatt hour or something like that. So you decided that, you two parties decided that, well, this party two will buy electricity from the electricity service provider only if the price goes below certain level. Then the contract will be automatically executed. And in return, monthly, for instance, party two will, send some money to party one. So this kind of a contract, you can agree on, and then you can write and then put it in the blockchain. And what the smart contract will do, it will look at the price of electricity. It will monitor the price of the electricity. And the moment it goes down below the threshold, let's say 3 cents, then the contract will be automatically executed. So contract will be made. And then party two has to pay something, if whatever it is written in the contract. Maybe 3 euros, 5 euros, or whatever has been decided based on the contract. And how do it monitor? How does it monitor? I mean, the price of the electricity. So from external sources, external data sources, it will read, the smart contract will read data from external sources and monitor. And then once it is executed, so then the transactions happens, right? So contract executed, a contract happens, and then some money has been transferred. And all these records are stored in the blockchain. So that's the kind of, the rough idea, rough use case, rough usage of a smart contract between two parties. Okay. Now I think you all know quite a lot about a smart contract, right? Now I will ask you, and please speak, I will ask you, what kind of advantages of a smart contract you can think of? Please open your mic and say something. What are the advantages of using a smart contract? Anyone?
Sir, there are automatic systems, so there are less chance biases.
So automating, and then less chance of what?
Biases.
Bias.
Sir.
Okay, bias.
And
Biasness, or
non-repudiation.
maybe error, lack of error, maybe.
Yes.
Okay.
It's a kind
Okay.
of trust and transparency.
Sorry.
Transparency along with non-repudiation.
Trust and transparency.
Trust and transparency.
ये आवाज आ रही है?
Trust and transparency it provide.
So they are immutable.
They are immutable. Okay, immutable.
So security.
Yeah, security. Okay.
It is reliable.
Non-repudiation.
More reliable. Yeah. Okay.
Non-repudiation.
What is that?
Non-repudiation.
I didn't get the. I'm not able to get the.
Faster and cheaper.
Faster. Fast to execute. I mean. Okay. Yeah. So it automates the.
One cannot deny a transaction he has done. So it promotes non-repudiation.
Okay. Okay. Yes. Yes. Okay. So I think I got quite many points already. Yeah. Now let's see what I have here. And I think what I have here is kind of similar to what you have said so far. So, so for instance, someone told at the very beginning, it automates the process. So as you can see, I have this point called autonomous execution. So the idea here that once you agree with the terms and conditions of the smart contract, when you deploy it, it is then automatic. You don't need to do anything. For instance, the example that I was giving in the previous slide, there, the smart contract monitors the price of electricity and then execute things by itself. So no human intervention is there. And then I think you also mentioned about error or biasness, but maybe the biasness is not the right term, but error is probably the right term in this context. So, the thing is, if you are sure that the smart contract is right and you have checked everything properly and then deployed it, then the manual error possibility is there is no manual error possibility, no human error possibility. However, if due to some reason the smart contract was not correct, there were some bugs or some problems were there, then it's a problem. But if it works fine, and then if you deployed it, then there is no manual error. For instance, as I was saying in the previous example, that the smart contract monitors the price of electricity, or market price of electricity. So in normal situation, maybe a human needs to read it every day, and then manually do it every day, and there is a possibility of manual error. But here, there is no possibility of manual error. Okay, and then somebody also mentioned about trust. Because you know that it is going to be saved in blockchain. You are sure about your the code that and contract. So the execution is trustless, or basically means that you can trust it. And then no middleman. So I think in your definition you also mentioned that smart contracts are between two parties without the need for bank or lawyer. So no middleman is involved there. So that's also an advantage. And somebody also told about immutability. Yes. So if you put the blockchain, deploy the blockchain, deploy the smart contract, then it cannot be changed. So immutability is there. Then reliability, definitely reliability is there. Savings. So as there is no middleman, savings is there. Automatic execution, so savings are there. And this very important thing is this code. Code is law. So what we are basically having here is a contract written in codes. So code is the law. And then default backups. So means that things are in blockchain in decentralized fashion. So these are all the advantages we can think of smart contracts. Then again, I think similar things that I was telling in the previous slide. For instance, autonomy. So smart contracts can be developed by anyone. No need for intermediaries such as lawyers, brokers, auditors. These are executed automatically. So autonomy is there. Efficiency. Removing process intermediaries often results in significant process efficiency gains. So they are efficient. Once you deploy it, once it is there, they are automatically executed. So they are efficient. Backup, as said, that things are stored in blockchain and permanent record. It allows auditing. Traceability is there. So, a good thing. Accuracy. Replacing human intermediaries with executable code. So it's more accurate, right? And then finally, cost savings. As I was mentioning in the previous slide, that it removes the intermediaries. So often significant cost reduction happens. So those are smart contract advantages. Now we'll talk about Ethereum development. So before that, I would like to briefly talk about Ethereum because I understood from today's these gamified quizzes that there are some students who probably do not have much knowledge on blockchain. So I will briefly talk about first Ethereum, and then we will talk about these development tools and Solidity language and then we will have the hands-on things. Okay. So Ethereum. So I think you all have by this time heard about it, Ethereum, right? So Ethereum is basically a blockchain, right? A blockchain development platform. And Ethereum has the native currency called Ether, ETH. Can you mute, please? Can you mute? Can you mute? Yeah. So Ethereum has the native currency called Ether. Bitcoin, for instance, have this currency as BTC or Bitcoin. So Ethereum allows you to write a smart contract. Bitcoin didn't allow you to write a smart contract, but Ethereum does. And you know what is a smart contract. So its programming of autonomous transactions are possible. So with the help of smart contracts, we can program automatic transactions. Not only that, with the help of a smart contract, we can develop decentralized applications, which are also known as DApps or DApps. So in DApps, what happens that in the backend you have the smart contract, and then in front end you have let's say some web web type of things, or so user interface and so on. So smart contracts kind of the building block of decentralized applications. And a DApp is an application built on decentralized network that combines a smart contract and a front-end user interface. Exactly the thing that I was saying, that a smart contract is in the backend, and in the front end you develop some user interface and then interact with this backend thing. Backend is smart contract. Okay. With the help of Ethereum, also Web3 applications are possible. Do you know what is Web3, by the way? Can anyone say what is Web3?
Yes, sir. They are create meme coins.
Sorry? Can you repeat, please?
They are create a meme
Decentralized
coin, I think.
Yeah, so somebody else also saying something. Okay. Yeah. So Web3 refers to, for instance, in Web3, you can develop things, develop apps, develop programs that run on the blockchain. These are the apps or services that allow anyone to participate without monetizing their personal data. So there is no restriction of participating. For instance, let's say in Twitter platform, that's Web2 platform, let's say that if Twitter decides to delete something, they can delete it. But if we are talking about a Web3 version of Twitter or Twitter-like platform, then it is decentralized. Then one person or Twitter cannot remove things, right? So basically the idea is that Web3 applications are running on top of decentralized systems like blockchain. So that's Web3 applications. Can you think of benefits and drawbacks of Web3 applications? So as said, benefit could be many. For instance, as said that I mean it is decentralized in nature. So basically, if Twitter wants to remove, they can remove, but the Twitter version of Web3 or Web3 version of Twitter, uh, that's not that is maintained by many actors. So it's not easy to remove. It's not possible to remove something from the platform. But what are the drawbacks? Yeah, the drawbacks are similar to blockchain, because Web3 is building on blockchain, so the drawbacks are similar to blockchains. Throughput is one problem. More processing power is needed, maybe. So all those problems that drawbacks that blockchains have, Web3 could also have similar things, similar problems, and similar benefits. Okay, so that's very short introduction of Ethereum. But then in Ethereum, there are different types of accounts. Do you know what kind of accounts Ethereum has? Anyone? At least two types of accounts. Two types of accounts there are. Anyone can say what are those two types of accounts?
Normal users and validators.
Normal user can have certain type of account, yes. Okay, this is a bit
Second
tricky
one,
question.
second one is
Contract
validator.
account.
Yeah, contract account. Yeah, somebody told contract account. Very good.
Account and externally owned account.
Yes, 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 yes. Very good. So there are two types of accounts. So one is externally owned account. So that is owned by individuals. And it has this private key, public keys pair that we were discussing yesterday, right? And if you want to create such account, it costs nothing. And you can create as many as possible. It costs nothing. Yeah. And you can, once you have it, you can, transfer, you can send and receive Ether in such accounts. But then there is this contract account. So contract account is smart contract deployed to the network, controlled by code. So contract accounts are controlled by code. And contract account always costs something because it uses the network. So you need to deploy the contract. So, and deploying, it costs. We will come to that. But for now, think that there are two types of account, individuals and contract. Okay. So those are the two account types, briefly. And then let's talk about the Ethereum virtual machine. And I think when I asked about this, you have already mentioned what is it. So basically, you know already, but then I have a little bit more information here. So this first thing you already know. The Ethereum virtual machine, or EVM, is a decentralized runtime environment. Okay. So you already mentioned about this. And you also have mentioned about this. It executes smart contracts on the Ethereum blockchain. So you also mentioned this. Every Ethereum node runs an instance of the EVM. So every Ethereum node runs an instance of it. And the smart contracts that you will execute in Ethereum virtual machine, those needs to be written in languages, especially with Solidity. So Solidity is the language of instructions, language of coding. And then somebody also mentioned about this bytecode. So compiled into bytecode. So when you compile the code or smart contract that you have written, then it generates bytecode or low-level machine instructions. And then the smart contracts are deployed on Ethereum and stored on the Ethereum blockchain. And EVM executes the bytecode, the low-level machine instructions, after the compilation. So that is executed by the Ethereum virtual machine. Okay. A little more about still Ethereum virtual machine. So the point here that, okay, we have the Ethereum virtual machine, but why would you be able to execute it? So for that, I mean, you must need to pay something. Otherwise you cannot execute it because it's a computer. It's a virtual machine, and if you want to use it, you need to pay. So for the pay, this gas is the gas is the kind of the pay. So gas is required for computations in the EVM. So when you and because you pay, it prevents infinite loops and denial of service attacks. You need to pay. You need to have the gas. So you cannot have this infinite loops. You will be out of gas. And then if the computation is more, then you need to pay for more gas. And how do you pay for the gas? So users pay gas fees in Ether to execute the transactions. So for instance, you can think that for each function or for each instruction in the smart contract, you need to pay for the gas. And you pay it for with the help of Ethereum. So each function, if you want to execute, it consumes some gas. And then equivalent gas price you need to pay via using Ether to execute the transactions. And then Ethereum has its mainnet, public mainnet, so which is the real net, the real network. And then in the real network, if you deploy something in the real network, you need to pay real Ether. And as you know that Ether is so expensive, you cannot really deploy there without making sure that your codes are good, codes are okay. You cannot test it there because it costs money, it costs Ether. So mainnet, you cannot really do. So basically, you need to use these test nets. And in the test nets, you use your smart contracts. You test your smart contracts. And once you test it and you are sure that okay, it works with okay, no problem. Only then you pay and then deploy it to the mainnet. So there are many test nets. So the Ethereum development platforms, Ethereum provides many test nets, and you can use one of those test nets to execute your smart contracts. And when you are happy with it, everything looks okay, then you deploy it to the mainnet. So this is how it works. Then this thing called Ethereum Stack is there, and in this website you will find many things about about Ethereum. I will show you briefly later. But before that, let me continue still with the slides. But in this link, you will find all the documentations related to Ethereum and Ethereum virtual machines, and everything you will find. And then about the smart contract language for Ethereum. What are the languages? There are basically two most popular languages for Ethereum. The first one is the Solidity I already mentioned, and Solidity is object-oriented and high-level programming language. And the codes, if you look at those codes mindfully, you will see that the codes are inspired by C++. And then the other one is this Viper. Viper is Pythonic programming. Looks like that. So, but in this course, today I will mainly show you Solidity. I have never used Viper. Solidity mainly I have tried in the past many years ago, because nowadays I don't try them because I have my students, PhD students and TAs, they do that. And I do, more abstract things, but I will show you some examples of Solidity today. Then, so let's assume that, okay, so we wrote the codes or smart contracts on Solidity. And then the question is, how do we compile? Or where do we compile? And what happens after compiling? So again, I think somebody mentioned about bytecode when I was asking about EVM. So in EVM, after you compile the smart contract, a bytecode is generated that can be run by the EVM. And bytecodes are also called opcodes. And they are, as I mentioned earlier, that they are low-level instructions that the EVM or Ethereum virtual machine can execute. And each opcode represents specific operations. And the operations could be of different things, different types: arithmetic operations, logical operations, data manipulations, data imputations, and so on. So the thing is, you write your code in Solidity language, which looks like C++. And then when you compile it, it generates a bytecode or low-level instructions that can be executed in Ethereum virtual machine. But then it also generates another thing, which is called Application Binary Interface, ABI. And why is that? Because ultimately your front end or web application needs to understand the contract and call the contract's function. So as said that, a smart contract is on the back end, and the application needs to call the functions of the contract. And for that purpose, this application binary interface or ABI is used. Okay. Okay. Very good so far. Then I would like to show you a very simple smart contract. And it's starting with the famous Hello World type of smart contract. Okay. So as you can see, so just take a look at the codes here. I will explain the codes later in the later slides, and then I will copy this code.
Unutilized जो फंड था वो वापस करना था ना, उसका कुछ प्रोसेस कर रहे हैं?
Sorry, can you mute yourself?
नहीं,
Or did you ask any
मैन
question?
only manpower की बात है। नहीं वो
Did
आदमी
you-
मेल
Okay. Okay, so this is a sample smart contract. And so what it is doing, it is initializing with the message called hello world. And then it can read a message, get message with this get message function, or it can set a message with the set message function at the end based on the user's input. But then I will explain each part of this code in the next slide. So let's take a look on these first two lines where it is written SPDX license identifier and then pragma solidity. So let's start from there. So in the next slide, you will find that. So the first two lines is about license and solidity version. So this is the license and this is the solidity version. Yeah. So as I have written here, this first one is a license identifier for open source contracts. And then the next one is specifies that this contract is written for solidity version 0.8.0 or higher. So this is about the version. So license and version, first two lines. And then declaring the contract. The next code was declaring the contract. So this is how we are declaring contract, hello world, and then we are defining a string called message. So contract hello world defines the contract named hello world, as you can see. And then with string private message, we declare a private state variable message that stores a text or a string. So this is our contract. And the private keyword means this variable is only accessible within the contract. So you know. Then the next function was this constructor function. So the constructor function begins like this. And then initially, the constructor function has the word hello world. So the constructor function runs only once when the contract is deployed. So it initializes the message variable with hello world. So it is executed or it runs only once when it is deployed with the initial message of hello world. So this is the constructor function. And now we will get a message. So the program or the smart contract initialized with the message called hello world. And now our role, our task is to read the message or get the message. And for that, we have this function get message and public view returns and then return message. So public means anyone can call this function. And view means it only reads data from the blockchain. It doesn't modify it. So it just views. So it just reads the message. And public means anyone can do that. And then returns string memory. The function returns a stored message. So this is for reading the message, viewing the message. So basically, we will read the message called hello world here. And then let's say that you want to set a new message. Instead of hello world, you want to set a new message. So initially it initialized with hello world, but you want to change it now. So the function to set message. So function set message public, and then message equal to this new message. New message is a variable. So again, the function is public, means anyone can call this function, and then it accepts a new string as message and updates the stored message with based on the user's input. Okay. Now I will now copy you. I will now share something else. I will copy this thing, and then I will execute it. Just a moment. I will I will execute it. Where is it? So let's copy it. Control C, and then I will start a new screen sharing. So you can see my screen, new screen. So this is called this Remix IDE, where you can test different smart contracts. You can basically compile and deploy in different test nets. So just quickly, I can show you some of the things. For instance, here you have this compiler. Here you will compile, and then you will deploy here. And then about here in this, you can see that there are different testnet. Remix virtual machine Cancun, for instance. And this account I have, and I have in account, I have 99.999 Ether. Here you can see the estimated gas it will show. And then here you will see the value or in Ether, right? So, and then you have this deploy button here. When you are done with compiling, you can deploy. So now, if I go to this file explorer, let's try to make that contract. So let's take a new file. Oops. Oops, what happened? Just a moment, please. Yep. So now I have, let's click, let's put a name of our smart contract. So what is our smart contract? Simple number, simple message store. So this is our smart contract name, in a file name. And what I'm going to do, I am now copy pasting my code here. And as you see, I have now copy pasted. And it looks like this. Okay. Now, what I will do, I will go to this compiler, Solidity compiler, and then I will compile it. Okay, let me compile this one. I have compiled it. And as you can see here, this generated bytecode and ABI that I mentioned. And you can copy also the bytecode and ABI just to see what kind of things it includes. You can see that. But anyway, it has been now compiled without any problem, right? And now I will go to this deploy, and then I would just deploy this smart contract. And it has been now deployed. And here you can see below deployed contracts. Under deployed contracts, you can see Hello World has been deployed. So if I click here, you will see set message, get message. So we had two functions, if you remember. We can set a new message, or we can read the message. And you remember initially the smart contract initialized with the word hello world. So if I click here, I will see hello world because it initialized with hello world. But then if I want to add, update the message, set the message, update the message with, let's say, with my name. I wrote my name there, and then I can set it. So I now set, I have now set the new message with my name. And if I now read it, you can see my name is there. So the message has been updated. Nazmul Islam is there. So this is a simple, very simple smart contract that I am showing you. Now what I am going to do, I will copy paste this code in the Teams chat, and then I will also copy paste the address of this Remix IDE, and then you go there and create your run this smart contract the way I did. And once you are successfully run it, then I will go to the next one. So let me now copy paste the code to the Teams message. So here you go. I have given, and now I will also give you the link to the Remix IDE, and here you go. So go to this remix.ethereum.org, this IDE, go there, and then create a new contract, copy paste my code, and try to run it. And maybe it will not take much time, maybe 5 minutes, 5 to 10 minutes, maybe. And then tell me that everyone managed to run it. And meanwhile, I go and make a little bit coffee. So yeah, try it, and I'm coming back in 5 minutes, 5 to 10 minutes, 5 minutes. Okay. Okay, how is it going? Did you manage to do it? Anyone?
Yes, sir, done.
Done. Okay. Is there anyone who
Yes, sir.
couldn't do it yet?
Done, sir.
You did it?
Yes, sir.
Yes, sir, I did it.
Okay. If somebody has not managed to do it yet, I can explain. You need to let me know if you didn't manage to do it. Okay, it seems everyone has managed to do it because no one said anything that he or she couldn't do it. So maybe everyone managed to do it. Okay. But what do you think? Is the code clear? Did you fully understand the code? I will, of course, I have more examples. When I will show those examples, things will be much more clearer, I believe.
Yes, sir, till now clear.
Okay, okay, very good. Okay, then I continue with my next smart contract. I will stop sharing this one, and then I will again share the slides. Yeah. Okay, so we tried this hello world thing. Why it is not moving? Okay, so we have tried hello world, and we move on. And yeah, yes, this is the another one, similar example, but in the previous one, we try to set a message or a string, but here we are trying to set a number. And as you can see that again, it starts similarly with license and version. And then we have a contract of simple storage where we are storing a private variable we are defining a private variable to store an unsigned integer. And then in the next function, this function set number, we are updating the stored number, and then with get number, we are retrieving the stored number. So the idea is pretty similar. So we are setting, or you are storing a number, and then we are retrieving a number. Okay. So similarly, I will just quickly run it on my computer. And then I will also send it to you so that you can also run it in your own computer. So similarly, let's again create a file. Here is like number store is our smart contract, and I copy paste here. I have copy pasted, and then I will now compiled, and then I will go to deploy. Let's remove the previous one. Then if I deploy, and then we have deployed the simple storage. And as you can see that we had two functions, set number, get number. If we get number now, we get 0 because we didn't set it. And set number, if we set, let's say 12, and then we are setting the number, and then if we now get the number, we get 12. So similarly, I will now copy paste the code to you. But why I'm not able to copy paste now? Yeah, I will copy paste now and just try this one. Similar thing, but try this one. And again, I give you, let's say, okay, three minutes. This should be pretty fast because you did it. So 3 minutes, and then we go to the next one.
Done, sir.
Okay, done. Okay, maybe I still wait two more minutes because maybe some people could be little slow. Let's wait for 1 or 2 minutes and then we go to the next one. 1 minute more. Let's wait.
Done, sir.
Okay, very good.
Done, sir.
Yes, sir.
Good, very good. We are doing good. Okay. Now I have a little bit difficult task for you to do. But why I cannot minimize each time? What happened? What? Yeah. Okay. So the next task is this. Can you see the next task? This is a classroom task 1. There are 2 tasks basically, two subtasks. The first task, subtask is, but can you see my screen by the way? Can you confirm?
No, sir, your screen is not visible now.
Oh, okay. Yeah. How about now?
It's visible now, sir.
Yeah.
Yes, sir.
So there, as you can see, that there is a task. There are 2 tasks here. The first program that we wrote is Hello World program, right? So I'm asking in the first subtask that extend the Hello World smart contract with the possibility for the user to write his or her preferred message instead of Hello World. So as you remember, the Hello World was, I think the contract was initializing with the message Hello World. But instead of that, let the user initialize the message with his or her own choice. And then also add a new function to remove the message. So previously we had set message and get message. But now I'm asking also to remove the message, to delete the